welcome everyone. This session we're going to talk about integrated ML and using integrated ML with H2O AutoML, which is built into our integrated ML offering. And just as a way of introduction, I'm Thomas Dyer. I'm product specialist at InterSystems, and I have here with me Erin Liddell, who's a chief machine learning scientist at H2O, to describe her baby, essentially, which is the AutoML engine that powers H2O's AutoML offering, I suppose. So what we're going to do today is I'm going to tell you a little bit about what integrated ML is, which is a feature of InterSystems Iris data platform. And then Erin's going to talk about H2O as well as the company, as well as the H2O AutoML program. So what we think you should get out of this is, you should be able to understand, how integrated ML leverages H2O, and also how you can, how H2O works and what kinds of engineering is under the hood with that system, and how it arrives at the best models that you can get given a certain data set. And then also you should be able to use some of the options. One of the great things about the H2O engine is that it has a lot of configurable options, so that if you have some tricky data set, you might get some better performance by tweaking some things. So that's about the extent of it. So let's get started. So I just talk a little bit about integrated ML. So the thing to understand about it is it's a component within InterSystems Iris, which is a full-featured data platform. One of the big parts of our data platform is a full-featured SQL engine. And so integrated ML is actually built within that SQL engine. And integrated ML is just really some simple DDL and query functions that are kind of like custom syntax, but should be very familiar to people that are really familiar with SQL. When you install Iris with integrated ML, you get these machine learning frameworks installed. As you see on the right, we have scikit-learn, XGBoost, and TensorFlow that are integrated as part of the InterSystems AutoML engine, but you also get H2O. And it's a very simple thing just to switch between them. And as you see in the first part there, in the center of the screen, there's some syntax that you can use in integrated ML. And that first line is to set ML configuration %H2O. That is the way that you would actually switch between these engines that are underneath and switch it to the H2O engine. And then everything you do when you train models and then actually get predictions from those models, it's using the H2O engine at that point. And just to underline, those models are then just exposed through SQL. After you train it, it's ready to use in SQL with a simple function that's called predict. And so you do a select with a bunch of data and put a predict function call in there, and integrated ML knows how to take all the inputs from that and from the select statement, from the result set that you get, and pass it to the model and actually get a prediction out of the model. So digging a little bit into how this actually works with H2O, the train model statement that you use to actually kick off machine learning, it actually ends up sending the data. But here's how it looks. You just do train model. You have the name of the model that you want to train, and then you can set up the table that you pass to it with a from clause, and then where clause you could modify which data you actually send to the training process. And then the very important part is a using clause at the end of all of that. And that's totally optional, as is the where clause in general. But using can come at the end with or without the where. And then you have some JSON formatted string you can send at the that you can put at the end. In this case, it sets the seed, which you might want to do to have some reproducible process, get reproducible numbers out, because oftentimes the algorithms will use some random number generator, and so this passes along some particular seed that you'll want to use over and over again. And then the next little bit there is a max runtime sex. That's an argument that actually gets passed to H2O. And so then H2O engine will parse that and then actually set an amount of seconds that it'll use to find and train models. And so there's a bunch of other options, and I think Aaron will touch on a couple of them. But the general idea is that we have a very kind of thin wrapper around H2O, and we kind of expose it enough that you can do the things that you really want to do as far as the major options, but you still have the same kind of SQL syntax, so it's not a heck of a lot to remember, and you can just dig into the documentation of H2O and figure out some things you might want to try there, but it all fits within the same flow of doing your machine learning with SQL and maintaining your models and maintaining your training process in the same place that your data lives, and that can avoid a lot of kind of switching back and forth between context, and you go over into a Jupyter notebook or do some ETL to get your data out of the database, and then do machine learning in some other environment like that. It ends up sometimes causing some problems. So really, integrated ML is a tool that allows you to do stuff from SQL, if that makes sense for your business process, and we think it does in a lot of contexts. So with that, now you've got a little bit of an idea of what integrated ML is and how we're leveraging H2O. I want to pass it over now to Aaron. And please, Aaron, introduce yourself as well as H2O, and very glad to have you here. Thanks so much for being here.
Thank you, Thomas. And today I'm going to talk about scalable automatic machine learning with H2O. And my name is Aaron Liddell, and I'm the Chief Machine Learning Scientist at H2o.ai. And just briefly, H2o.ai is the name of the company that I work at. We're in Mountain View, California. Been around for about 8 years now. And H2O is also the name of the software that we produce. So it's open source. And essentially, it's a distributed machine learning platform sort of geared towards big data. So I'm going to briefly talk about H2O just at a high level quickly to those of you who are not familiar. And then I'm going to talk a little bit about AutoML, and then what is H2O AutoML, and then I'll send you home with lots of resources and links where you can learn more about it. Okay, so for those of you who are, in the data science field already, you've probably heard of something like scikit-learn, which is sort of a Python package for doing a whole bunch of machine learning algorithms and analysis and stuff like that. So H2O is very similar to that if you're not aware. So the main difference is that we are scalable. All of our algorithms are distributed. It's sort of an enterprise grade level version of that type of system. And when we started the company in 2012, the industry was very focused on this new thing called big data. So one of the goals was to write a machine learning platform that would scale to these very large data sets and do very fast machine learning, and also to make it easily deployable. At a high level, what we have in H2O is a bunch of supervised and unsupervised machine learning algorithms, sort of all the ones that people like to use that are popular, like gradient boosting machines, random forest, deep neural nets, stacked ensembles, etc. Another thing that is unique to H2O is we try to sort of automate all of the little sort of pieces that you generally have to do when you're doing machine learning, which have to do with like preparing your data. So if you have missing data, we fill things in automatically. We try to sort of auto-tune all the algorithms. And we try to just make anything that we can make automatic. And then we have other just auxiliary functionality like cross-validation, grid search, random search, variable importance, model evaluation metrics, and plots. So just kind of the whole, anything that you would really need to do machine learning, we put right in the package for you. So that's really just at a high level what H2O is, and you can use it through R, through Python, through Java, through the browser, and anything that can connect to basically a REST API, you can use it through. So I think that's one of the ways that it has been integrated into the integrated ML system. So why AutoML? So I'll just, there's a lot of reasons why, but one of the main reasons is there's something in computer science called the no free lunch theorem. And you probably heard that sort of as a colloquial saying as well. But basically what it says is that all algorithms are sort of equivalent when averaged over all the problems. And what that means is essentially there's no single best algorithm. So, it would be great if there was just one algorithm and we would always just use that one for every data set and it would be pretty easy, but that's just not the case. So we have to, when you're trying to find the best algorithm for a particular data set, you have to try a bunch of things. You have to try a lot of different algorithms, a lot of different settings for all the algorithms. And one way to sort of make that process easy is what we call AutoML. We sort of automate that whole process of finding the best algorithm. So some of the goals and features of AutoML. So the main goal really is just to train the best model with the least amount of time. And so by that we mean the least amount of time that, like, computation time that it takes to run the algorithm, but also the user's time to write all the code to set that up. So we try to minimize on both ends as much as possible. So we make it as simple of an interface as possible. You basically just have to point to your data set and tell it how long you want it to run. So as a consequence of that, it really reduces the amount of human effort and expertise required in machine learning. So maybe 5 or 10 years ago, as a data scientist, well, I don't even know if people were calling themselves data scientists 10 years ago, but you used to have to be an expert at every single algorithm and all of the hyperparameters and tuning everything. But these days, this is where everything is headed towards simplifying and automation. And so this can be used for a lot of different reasons. And there's a lot of nice benefits of AutoML, including just making it easy to do lots of scientific research without having to be a machine learning expert, or industrial research. Any type of applications of machine learning have been made easier by this. So here's some of the features just of sort of machine learning in general. So this is kind of my way of dividing up the different tasks. So there's something that we would call like anything to do with data preparation. That could be one aspect. Then there's just generating all the different models. So at the beginning, remember, we talked about how there's not just one algorithm that's always going to be the winner. So we have to spend a lot of time evaluating a whole bunch of different algorithms. And then lastly, this is sort of an optional thing, but if you really want to get the best performance, generally what you do is you combine a number of different algorithms together into something that we call an ensemble. And if you're new to AutoML, I'm just sort of pointing out this blog post that I wrote. It's almost 2 years old now, but it sort of introduces you to the field of AutoML. There's all different types of AutoML. Depends a lot upon like what type of data you're looking at. If you have image data, that's one type of AutoML. If you have tabular data, that's another. So if you're familiar, or if you want to get familiar, this is a good blog post to read. Okay, so for H2O AutoML, this is just a high level overview of what we do. So in all the H2O algorithms themselves, we have some sort of automated basic data pre-processing steps. So we kind of get that for free in AutoML because it's already included in all the algorithms. We have recently just added some more sophisticated data processing in AutoML, which I'll talk about on a future slide. And the process kind of goes as follows. So we train a random grid. So like if you're not familiar with that term, it just means we try a whole bunch of combinations of settings for each algorithm. Like for the gradient boosting machine algorithm, we will try a whole bunch of different settings, and then one of those will be the best. Same goes for all the different algorithms that we try out. And part of what we've sort of provided you in this is that we've limited the scope in a way that we try to sort of get you the best models possible quickly. So one of the hard things about data science is how do you even know, what hyperparameters to look at and what value ranges you should look over, because you could spend a lot of time basically trying every possible combination, but then it would take a very, very long time to get to the best solution. So we try to limit that space in sort of a smart way to get you there quickly. We tune all the models so that they're not overfit. So that's just, another concept in machine learning is overfitting. We try to avoid that in an automated way. Then once we, have trained all what we call the base models, sort of the models that are not part of that are not the ensemble, just the regular models. Once that's complete, we train 2 what we call stacked ensembles, which is just a particular type of an ensemble. And one we train with all the models in it. So you kind of get this gigantic super model that has everything that you've trained in it. And then we also give you a more lightweight version. So one of the reasons that you might not want to use an ensemble with, let's say, 200 or 500 models in it is that it is a little bit slower to make the prediction. So we try to sort of optimize that by choosing the best model from each algorithm class, like the best GBM, the best random forest, et cetera, and make a little lightweight ensemble that's more ready for production use. And then what you get back is something that we call the leaderboard. And basically what that is a ranked list of all the models that you've trained, ranked by their performance. And I'll show you an example of that in a minute. And then because we're using H2O, makes it easy. All these models are just H2O models, and that makes it easy to export them into production. So this is just, this is probably not how you would use this in the integrated ML system, but just so you're aware, this is kind of the basic interface in Python. There's essentially, 2 lines of code to train the AutoML object. So first you create the class and you tell it how long you want it to run. So we say max runtime sex equals 600, which would be, run it for 10 minutes. And then we execute the train method and tell it what data we want it to train on. So we tell it the training set, which is basically, in this example, a CSV file, but it could also be, a table in a database or any kind of tabular format of data. And then we, generally have a column in the data that is the column that we're trying to predict. And we say y equals the name of that column. So it just knows which one it's trying to predict. And then, it will do its thing. And then what you get back is this object. And one of the main, objects inside of the AutoML object is what we call the leaderboard, as I mentioned. And then if there's any R users watching this right now, here's just a quick look at what it looks like in R. And then we also have what's called the flow GUI. So every time you start an H2O instance, you automatically get this other interface that you can use, which is accessible through the browser. And you can do everything the same. You just, instead of writing code, you're clicking around and you're selecting options and stuff like that. So it's very simple to use, even if you don't know how to write any code. Okay, so here's an example of what the leaderboard is. Like I said, it's just sort of a ranked list of all the models. Here you can tell what type of model it is just by looking at the model ID. And in this case, we see the stacked ensemble with all the models is doing the best here. So AUC is the column that it's being ranked on. So for binary classification, there's lots of different metrics you can use to evaluate the performance. But AUC, or area under the ROC curve, is kind of one of the main ones that you might use. You can change that. That's one of the options that's configurable. So we're ranking this by AUC, and then you can see a couple different types of models here. This is just a little, screenshot of the top of a leaderboard. There would probably be more models of different types below in general. And then just a few pro tips, like how do you customize? So this would be that string of JSON that Thomas mentioned that you can customize. The example he gave is, just controlling the time limit. That's kind of the main and obvious thing that you can do. You should always consider how much time you want to spend. And then you can limit either based on time or the number of models. So, or both at the same time, and it will stop when it meets the first one of those. So that's useful because, you don't want it just to run forever. You want to sort of, run it for an hour, run it for a couple hours, run it for 10 minutes, whatever you want, and then check in and see how it's going. And then if you have big data sets, one of the things that we generally would suggest is either lowering the number of cross-validation folds to like a lower number. It defaults to 5, so maybe you would lower it to 3 or 2, or just you can completely turn it off to 0. This is something actually that we're working on right now to do automatically. So we'll kind of take a look at your data, and based on the size of the data, and then compare that to the size of the resources of the machine, we'll try to make some smart guess as to what would be better, most efficient here. But by default, it will just do 5-fold cross-validation. And in order to do stacked ensembles, we have to have cross-validation. And I'm not going to go into details why, but that's something you can do. And then if you want to turn on and off certain algorithms, you can also do that using those arguments. I have very little time left, so I'm just going to say a few more things. So we now have model explainability for both AutoML objects and regular H2O models. This is just an overview of what's available there. And if you're curious, like how do these AutoML systems compare to real people in real life, real data scientists? So, one of the goals is we don't ever want to replace data scientists, but we found that on a very short scale, let's say you have like a 1-day competition, AutoML engines do tend to do better than, like an average data scientist, let's say. However, if you do have like more than a day to spend on a problem, you can probably beat almost every AutoML system out there if you're a very sophisticated data scientist. So this is just an example of kind of where AutoML tools fall in terms of the context here. And so this is just where you can learn a little bit more. There's a number of different AutoML tools out there. There's not that many, but we've done some benchmarking there. And then if you want to learn more about the algorithm inside of H2O AutoML, we have a paper now published a couple months ago, so you can download that here. And then these are the links to learning H2O AutoML if you want to, get your hands dirty with R Python. And then the user guide, the top link here is probably the most useful because that'll show you all the parameters and how you can customize it. And that's some H2O resources. And I think the last slide is here, where if you'd like to get a hold of me, this is how you find me. So thank you very much.
Okay, well, thanks so much, Erin. That was really interesting, and I think people have a lot of resources there. They can learn more. But absolutely, you can see that using H2O is really easy, but there's a lot of power underneath there. A lot of optimization has gone into giving a really good result with very little time and very little effort. I mean, just a couple of lines to kick off all of that power under the hood is really a feat of not only engineering but user experience. So really nice. Thank you very much. And so we do have another session where you can learn more about integrated ML within this virtual summit. There's also resources on the Learning Services Guide, and you'll have access to these slides, and you'll be able to click on any number of links. So thank you very, very much for your time, everyone. And absolutely get in contact with us. Reach out to your InterSystems team to learn more about integrated ML and Iris, and absolutely reach out to Aaron with any questions about H2O. Absolutely thrilled to have been able to do this. Aaron, do you have any closing thoughts?
No, it's just really, great to see integrations like this. This is kind of what we would hope would happen when we put out this open source code and make it really simple. So Absolutely. Thanks for doing that.
Okay, well, thank you, everyone, and have a great rest of your conference.